Hey, it's Wednesday the 13th, about quarter till 12 in the morning. Obviously, I'm not about to do astro at this point. We have a very nice sky, a few faint, thin clouds, some atmospheric water to the south and to the southeast, where the moon will probably be rising probably around 11 o'clock this evening. I'll add that into my observing notes that I'm going to attach to this video. What I'm going to start with, I can't do this long because the sun is still shining into the observatory. I do want to show you the scope set up with 32mm Explorer Scientific eyepiece, which you can see there, and a 2X Barlow, also from Explorer Scientific. Of course, this is Skywatcher Evostar 150 ED semi-apochromatic refractor, which gives fine views unobstructed of the night sky. Total magnification on this Barlow pair is 75, and I think I calculated the area of view for the 62-degree visual field eyepiece is about 48 arc minutes. Using a Barlow lens and stuffed inside the and a diagonal stuffed inside the Barlow lens is an Optolong deep sky filter, which I'm quite pleased with. I did a thorough remodeling of the scope last night using the Gemini 2 and the Wasman DG11 mount on a tripod. Eventually I would want to put the mount on a pier. For the time being, any vibration in the floor below me tends to translate into some eyepiece wobble, which can be corrected for to some degree using the ZWO imager. And I have exposed deep sky studies up to 60 seconds, which approximates, well, I think about a 48-inch to a 90-inch telescope at the eyepiece. Of course, you would never view through a 90-inch telescope at the eyepiece because all the light cone would not fit into your retina, which typically requires 7mm dilation of the pupil, which we call the exit pupil. The exit pupil on this scope right now at 75x is 75 into 150mm lens is 2mm, which is optimal for any scope that's going to do a variety of deep sky studies. However, globular clusters, etc., and small planetaries can profit by boosting it to 1mm exit pupil, and sometimes you can make out the core of faint, very faint galaxies using 150x or 1mm exit pupil. This is the little table that I mount the laptop on when I'm doing ZWO imaging. I have a hand controller over here, a bunch of various items sitting on the eyepiece tray here. The scope barely fits in to Penty the observatory, and Penty is not a sexty because I only have so much floor space on the deck here. Anyway, and when I am observing deep south studies, the eyepiece is about right here, and I often have to use my left eye in order to get a view through the eyepiece, which is not a problem whatsoever with a ZWO imager because it feeds into the laptop. There's also cumbersome issues with local lights from neighbors. There's a street light over there, but it is the kind of street, I don't know if you can see it, but it is the kind of street light that uses amber lamps to help reduce the amount of effect on the iris. You want your eyes dark adapted before you do eyepiece astronomy, and that is not an issue when you're doing imaging. However, you do have some issue with stray light entering the optical tube, which diminishes the sensitivity, and you have to make adjustments using what is called the histogram settings, which also reduces your effective aperture. So there's a brief tour. I'll back off a little bit so you can see Penty the observatory a little better. I'm going to have to close it up. I don't want the sun heating up the optical tube assembly, but I do want to continue this video inside because I want to show you the observing plan for the night. Okay, you may have seen this video, El Quattro Bino Viewing by Moonlight, previously. Now, there's no imaging in this particular video on our Golden Phoenix Publish channel YouTube site. However, I do demonstrate various studies on a pad illuminated by an amber lamp. Now, I am not going to be using the 150 fast newt, which effectively reduces its aperture down to about 125 millimeter, especially when you add a Barlow lens, which splits the light, but losing 0.8 magnitudes through each eyepiece. But when you combine them both, again using your eyes, you add another 0.3 to 0.5. So effectively, a scope that ordinarily, if it were a refractor, could show stars at 150x 1 millimeter exit pupil down to magnitude 13.5 is effectively reduced because of the obstruction and the binoviewer to about 12.8 to 13.0 magnitude stars, and those would only be visible at 150x, this is roughly 60x, when directly overhead at night, and stars could be seen down to magnitude 5.5, or the Cygnus rift in the summertime was clearly visible in Cygnus, the Northern Cross, and the rest of the Milky Way shines quite brilliantly all the way down to Sagittarius. However, the last few nights of observing have not been that good. So, that is the video that I have been adding some commentary on, but the commentary was not based on the 150 El Quattro fast newt, but based on the 6-inch 150 that I'm going to now read into this, and then I will add some other notes so that I have like 15 or 20 minutes of video that I can add captioning in after I get this next observing plan out. Oops, press the wrong thing. Read more. Okay, I have an OBS report from the 808, August 11, 2025, when the moon was pretty seriously hampering viewing, especially late at night in the summertime when sky dark doesn't arrive until about 9:45. So, on August 11, 2025, I set up the semi-apochromatic f8 150 millimeter Eddy in Penty, the backyard observatory, which you have seen, with the 2-inch wide field 32 millimeter plus 2x bar and 2x Barlow for 75x 2 millimeter exit pupil in the late afternoon. I also threaded in a 2-inch Optolong deep sky filter to the Barlow. My basic goal was to begin with 50 millimeter deep sky studies from the Astro Geekjoy Deep Sky Atlas, which I will show you in a minute, and progress as early in the evening as feasible. All right. Beginning at about 9:10 PDT, I was able to view Messiers 5, 13, and 6, plus NGC 6530. That 9:10 time, I believe, was about a little more than an hour after sunset, so not quite sky dark. Beginning around 9:15 to 75 millimeter scope optimized M92. Now what that means is M92 on a good night of seeing stars neighboring to 5.5 should show some resolution through a 3-inch scope. So should Messier 10 and 12, which was faintly viewed. 7, 24, 25, and NGC 6633 were all visible. By 9:23, moved on to 100 millimeter space scope optimized NGC 6572, Messier 1662, 4, 8, 21, and 28. Beginning at 9:48, which would have been sky dark, but except for the blooming moonwash to the southeast, had flipped the scope east-facing to catch NGC 6818, 7009, 7027, and Messier 29. Views to deep south were hampered by poor eyepiece presentation. As I mentioned, I had to use my left eye. Of the various studies, Messier 12, NGC 6218, with data to follow, had an average surface, was the Vegas, so Messier 12 the Vegas. Later that evening, had a look for Galaxy NGC 6207 near M13. Data follows. Average surface brightness 13.1. Average brightness, which is a key concept here, of the cumulative magnitude 11.6 plus its average surface brightness per roundish arcment of 13.1 divided by 2 equals 12.35. And I have been able to see this at the eyepiece through a 150mm Maxitov. Not sure whether direct or averted. Decades ago, under dark sky conditions, should be able to see it direct through eddy once the moonwash has left our skies. Stay tuned in comments to follow. Basically, NGC 6207 is the holy grail for 6-inch scopists. The question, through which quality skies, what lunar conditions, magnification, using direct vision, averted, or eye movement. Averted equals a 9-inch view, eye movement at 12, which adds 1.5 magnitudes to your visual sensitivity. Note, M10 was easily seen, also known as 6254, with data there, was far more present in the eyepiece than M12 as described above. What's the hap here? It'll be very interesting if there's some data problems because they are very close to each other in the sky. So we're going to cancel out on that. Okay, a brief read on the OBS report from last night on the 12th of August 2025. Had eddy out as specified earlier. Did loads of pre-planning involving post-culminatory deep sky studies. 30 degrees south is as far as I'll go to 45 overhead, and then we get obstruction from the observatory. This involved 25 studies, 9 of which were Messiers and 16 were NGCs. 8 of the Messiers were at the top of the list for average surface brightness, which I've already described. Brightest AB was M13, NGC 6205, and the faintest was NGC 6384, and that was a pure NGC. These were 8.9, 12.1 respectively in terms of their averaged brightness. So Messier 13 was 8.9 and NGC 6384 was 12.1. The near overhead M13 could just be held direct 30 minutes after sunset, which really is interesting because during a Messier marathon you got to deal with Messier 31, 110, and 32, and they are very close to the horizon and you have to be able to catch them about 45 minutes after sunset in late March, early April. Near overhead was NGC 6384, was barely held direct. That was a 12.1 average brightness galaxy. Well after sky dark, which occurs 90 minutes after sunset. All studies less than AB 11.0 could be held direct regardless of where found in the sky by sky dark. That list included Messiers 13, 92, 4, 62, 10, 19, 80, 12, and 107. The 5 brighter than Messier 107 as NGCs were also held direct. NGC 6235, 6304, 6356, 6293, and 6316. Because all such were visible at the eyepiece before sky dark, they were at least vaguely held direct against a slowly dimming eyepiece backdrop. Vaguely means they were clearly, obviously, somewhat, maybe brighter than the background sky. At no time did the eyepiece view look pitch black, even after sky dark, just before, and that's typical of the 75X under 4 to 4.5 ULM conditions. Just before sky dark, all stars making up the Northern Cross could be held direct. I'm not sure of the magnitudes. I'm sure, now this is without my glasses on, so you can typically add 0.5 magnitudes, whatever is the faintest star in the Northern Cross. After sky dark, the Milky Way could be vaguely followed into Sagittarius, but the Cygnus rift was not visible. Skies can be estimated to have been 4.5 of 6.5 magnitude transparent. That's the typical range. 5.5 is the very best seeing I get here in John Day at 3,000 feet, and 6.5 I've experienced at 6,000 feet overlooking Crater Lake. That was a documented report on the astro.geekjoy.com website, which is no longer available. It may not even be able to find anywhere on the web anymore. The list of not seen NGCs progresses from NGC 6287, 6342, 6366, 6355, 6269, 6207, which is our bellwether, for a 6-inch scope. 6325, 6166, 6181. The unsenes ranged from average brightness 11.1 to 12.35. While averted sight or eye movement is likely to reveal all such, no effort was made to use the 6-inch scope to get 9 or 12-inch views by using either averted vision or eye movement. Averted vision typically adds 0.8 magnitudes to reach and eye movement 1.5. NGC 6309 and 6384 with average brightnesses of 11.5 and 12.1 were the exceptions. One is a near arc-minute sized planetary nebula. That was 11.5 AB, and the other a large galaxy seen in the sky's middle third, which magnitude was 10.6, but it covered a lot of space. Typically, galaxies in the 10th magnitude range do. This is something like 6 by 4, I think. Data on both, you can see it there. And you can go to the write-up on El Quattro Monoviewing by moonlight. Here are my conclusions. Low sky position easily loses 1 magnitude of AB to sight. Meanwhile, large, low, average surface brightness galaxies like 6384 can be vaguely held direct at 2 mm exit pupil, 75x through a 150 mm unobstructed scope. Anything above roughly AB 12.0 needs deeper seeing skies to be reliably held, and that depends on sky position. AB 12.5 or less should be seen in parts of the sky transparent to magnitude 5.5. 1 magnitude fainter on this occasion. AB 12.5 magnitude studies at 75x are 1 magnitude fainter than the stellar reach of such a scope operating at 1 mm exit pupil 150x. Keep in mind that Optolong deep sky filter helped correct for local municipal lighting, but such lights can and did have an effect on my dark eyes adaptation because it was constantly streaming in, though at a low level. Finally, even a deep sky filter, not a nebula filter, can distinctly reveal planetary nebula of reasonable apparent size. Down to 20 arc seconds are pretty straightforward. By the way, please visit Steve Gottlieb's Adventures in Deep Space website to research all studies, including this report, for further insight. If you do so and anything relevant comes up, leave a comment below. All right, one final read through. I have no idea why strike theories occur above. I mentioned that. Here are my rough conclusions and preliminary generalizations. A 50 mm wide field binocular, kind that goes on a mount, or astronomical binocular operating at 25x 2 mm exit pupil should reveal any study having an AB, which is defined here as the average brightness, equals the cumulative visual brightness plus the average surface brightness per roundish arc minute divided by 2. And that value generally has to come out to less than 9.7. A 3-inch refractor should reveal any study of less than 10.5 AB. A 6-inch, you add 1.5 because you doubled 3 inches to get 6 inches. To get 12.0, you double the size of to a 12-inch scope because it has 4 times the area, adding 1.5 magnitudes to get to the 12.0, and you get 13.5. An 18-inch scope, you can add 0.8 to a 12 and you get 14.3. A 24-incher, 15.0. A 36, well, that's half more. It's going to be 15.8. And assume stars to magnitude 4.8 can be held direct, nominal, not optimal, nor excellent seeing, the kind of a night you'd barely be willing to do eyepiece astro under. Through better skies, add 0.5 magnitudes for skies to the upper limit of what you'd expect to see, when the Cygnus rift might be showing 5.5 magnitude stars should be seen direct near the study. For me, that's 5 without my glasses on. And 1.0 for whenever you've banished all artificial light by observing at 7,800 feet on a high desert plateau. Meanwhile, subtract 0.5 for anything well placed but not in the sky's middle third. And that basically means when the sky starts to shift from being dark to being somewhat illuminated because the atmosphere is thicker, that's outside the sky's middle third. Then subtract another 0.5 for anything between 15 and 25 degrees above the horizon. Typically, I get decent views down to minus 25 degrees below the celestial equator from 45 degrees north. Anything below 30 degrees below the celestial equator, I don't even bother with. Of course, those 18, 24, and 36-inch views would likely be seen using an imager through a 6-inch scope. However, Steve Gottlieb has reported seeing at the eyepiece in some of his reports. He describes what you see at the eyepiece of a 48-inch scope, typically in the 400x magnification range. Meanwhile, all bets are off when viewing anything smaller than 1 arc-minute in size. That will require more investigation. Okay, now let me quickly review what I went through already. Last night I was looking to the south and overhead with the scope mount oriented to the west. Tonight I made a list oriented to the east. I will start with Messier 13 at a half an hour after sunset just to see what it looks like. I will then, and that has a value of averaged brightness of 8.9, so it should be reliably viewed and give a good view through those 50 millimeter 25x binoculars. Then we step down a little bit to NGC 6633. Probably, I don't know what that is. I don't list it here. I'd have to look it up. That's at 8.2, 6604 at 8.3. Then we move on to Messier 23, 6494, 9.1, Messier 18, 6613, 9.3, I believe. Then 6425 is a 9.5, 6626 is a 9.5, 6611 is a 9.6, and 6514 is a 6637, which is also Messier 69, is a 9.8, and then Messier 20, NGC 6514 is a 9.9. Once we get to NGC 6618, which is also Messier 17, we enter into the double-digit region, a 10 average brightness. 6624, 10.1, 6540, 10.1, 6402, 10.3, 6544, 10.3, 6553, 10.3, 6652, 10.3, 6681, also 10.3, well, what a spade. 6522 at 10.4, 6528, 10.9. Probably by the time we get to 10.9, we're going to need to have achieved sky dark. 6440 at 10.9. 6445 is a planetary nebula, smallish, 10.9, so it doesn't have an average brightness. 6642 at 11, 6694 at 11, 6638 at 11. 6453 at 11.3 average brightness, 6401 is 11.4, 6539 at 11.9, and the acid test will be NGC 6661 at 12.4. I also will look at Messier 57 to see if the 13.1 magnitude star can be seen at 75x. Typically it takes 150. I will look at Messier 27. I've had hints of the football shape of the dumbbell. And then I will go on to 6888, blew me away with the Optilon filter. Even the other night I could make out the Crescent Nebula. Astonishing. So that's the plan for tonight, and those notes will be used in sequence as the sky gets darker and darker, and I will include notes in the captioning of this video, but I will edit those notes tomorrow. I'm going to go ahead and put this video up now, and I probably will not include all of the reading and discussion on tomorrow's video when I follow up using this study, but based not on the fast F4 Newt, but based on the F8 semi-apochromatic, non-obstructed refractor that you saw earlier in this video. So, carpe diem by day and carpe noctem by night.